Welcome to MRL. In this learning session, we'll be learning the solutions of examples of exercise 12.2 of surface areas and volumes chapter of NCERT 10th standard CBSE textbook. So let us go with the first example now. Now we are given a solid formed by a cone standing on a hemisphere. So there is a solid formed here. There is a hemisphere and the cone is surmounted on it. The radius of the hemisphere is 1 centimeter and the radius of the cone is also 1 centimeter. The height of the cone is 1 centimeter. So now we have to find the volume of this solid formed. The volume of the solid formed will be equal to the volume of the cone plus the volume of the hemisphere. So it's a combination of solid figures. So we'll have to find the volume of the first, that is hemisphere, and then add to the volume of the cone. So therefore volume of cone plus volume of hemisphere. Now we know the formula is the volume of cone is 1 by 3 pi r square h and the volume of hemisphere is 2 by 3 pi r cube, and therefore here r is same, therefore we can take 1 by 3 pi r square as a common thing, and in the bracket we can put h plus 2r. Now 1 by 3 into 22 pi is 22 upon 7, r is 1 centimeter, 1 into 1, and because r square is 1 into 1, and h is again 1 centimeter and r is 1, therefore it becomes 2, 2 into 1 is 2. Now simplifying this, we get 22 upon 7, and we know that 22 upon 7 is symbolically represented as pi, and therefore the volume of the solid formed is pi centimeter cube. Please remember that. Now in the second example, we are given a model which is having a cylinder in the center and one cone on the left end, and another cone on the right end. They are attached to the cylinder. Now the diameter of the cylinder and also the cone is 3 centimeters, and the total length of the model is 12 centimeters. Now height of the cone is 2 centimeters on the left and 2 centimeters on the right. There are two cones, both are having the same height, 2 centimeters. Now we have to find out the volume of air filled in this particular model. Now we have three solid figures here. In the center we have the cylinder, on the left side we have the cone, and on the right side also we have the cone. So we have to find the volume, therefore we have to find the volume of the cylinder plus 2 times volume of one cone, because both the cones are identical. Now the volume of cylinder will be pi r square h1. Now what is the h1? h1 is the height of the cylinder here, and to find the h1 we have to subtract 2 centimeters on the left and 2 centimeters on the right from 12 centimeters, that is 12 minus 4 is 8 centimeters, therefore h1 is 8 centimeter, and therefore we have pi r square h1 is the volume of the cylinder, and also the volume of the cone will be 1 by 3 pi r square h2 is 2 centimeter here. Now substituting the values, pi r square is taken as common here, h1 plus 2 by 3 h2, pi r square is 3 by 2 because diameter is 3, therefore it is 3 by 2 into 3 by 2 into h1 is 8 plus 2 by 3 into h2 is 2. Now simplifying we get pi into 9 by 4 in the bracket 8 plus 4 by 3, pi into 9 by 4 into 24 plus 4 divided by 3, taking LCM there, and simplifying we get 22 into 3, that is 66 centimeter cube. So the volume of the model formed is 66 centimeter cube. A simple example, only try to understand and remember the formulas to solve them. In this example, we are given a glass in which there are 45 gulab jamuns, and each jamun is in the form of a cylinder with having the ends as hemisphere. So there is a cylinder in the center, there is hemisphere on the left hand side and a hemisphere on the right hand side. Together, all three solids together form one gulab jamun. Now there are 45 gulab jamuns in the glass. Now what we have to find is how much is the amount of syrup. Okay, the amount of syrup of 45 gulab jamuns we have to find, and it is the volume of the syrup is 30% of the total volume of the 45 gulab jamuns. Now let us see the parameters or the dimensions given. The total length of one gulab jamun is 5 centimeter, and they have given the diameter of the cylinder and the hemisphere as 2.8 centimeters. That means the radius is 1.4 centimeter here, radius is 1.4. Now 1.4 on the left and 1.4 on the right, and the total length being 5 minus 2.8 gives us 2.2, therefore the height of the cylinder is 2.2 centimeters. Now let us find the volume of one jamun first. Now volume of one jamun will be equal to the volume of the cylinder plus the volume of the two hemispheres. When I combine the two hemispheres, it becomes a volume of a sphere. So therefore I have taken volume of a sphere. And we know the formula is the volume of a cylinder is pi r square h, and volume of sphere is 4 by 3 pi r cube. Since r is the same, I can take pi r square outside, so pi r square in the bracket h plus 4 by 3 r, and pi is 22 upon 7 and r is 1.4 into 1.4, and in the bracket h is 2.2, that is height of the cylinder, plus 4 by 3 into 1.4. Now simplifying this, I can divide it by 7, I get 0.2 into 1.4, that will be 22 into 0.28, and 2.2 as it is, simplifying we get 5.6 divided by 3. Further simplification, I get the volume of one jamun is 22 into 0.28 into 12.2 divided by 3, that is the volume of one jamun. Now there are 45 jamuns, I have to find out the volume of 45 jamuns. That means I can multiply this volume of one jamun with 45, and when I multiply with 45 I get 330. So simplification is very simple, you can do that. 330 into 0.28 into 12.2 is the volume of 45 jamuns. Now the syrup is 30% of the volume of all the 45 jamuns, therefore I have to take 30% of that. That's why I have multiplied this by 30 by 100. So when I simplify it further, I get ultimately the answer is 338.184 centimeter cube. So therefore the volume of the syrup is 338.184 centimeter cube. I believe that you all know how to simplify this, and I insist that you learn how to simplify the decimals, and that is what is important for solving any of the examples of surface areas and volumes. So therefore ultimately the answer is given. Don't use a calculator, try to do it yourself and see that you get the answer. Now coming to the next example, in the fourth example, we are given a pen stand which is in the shape of a cuboid. So this is a pen stand, it is in the shape of a cuboid, and the length of the cuboid is 15 centimeters, the breadth is 10, and the height is 3.5. Now there are 4 conical depths or depressions cut in the cuboid to insert the pen, therefore it's a pen stand, therefore there are depressions. So I have shown you one depression here, and the radius of the cone is 0.5, and the height of the cone is 1.4 centimeter. There are four cones there formed. Now what we have to find is, when you cut a depression, wood is taken out from that, and therefore they have asked you to find out the volume of wood in the entire stand or the pen stand there. Okay, let us understand this. Now a very simple thing, first find the volume. See, the idea is we have to find the volume of the cuboid and subtract the volume of the 4 depressions of the cones formed there, and that gives you the volume of the remaining wood in the pen stand. Now volume of wood in the entire stand will be volume of cuboid minus 4 times volume of one conical depression, and the volume of cuboid, as you know, it is length into breadth into height, and the volume of one cone is 1 by 3 pi r square h1, and the height of the cone is 1.4. so we have to substitute the values here. So L is 15, B is 10, H is 3.5, 4 by 3, and pi is 22 upon 7, r square is 0.5 into 0.5, and the h1 is that is 1.4, that is 1.4, yeah, h1 is 1.4. Now simplifying this, we get 15 into 35, and that is 525. Simplifying this, I get 4.4 divided by 3. Further simplification, I get 523.53 centimeter cube. Therefore the volume of the wood which is there in the pen stand is 523.53 centimeter cube. So therefore understand here, the original volume of the cuboid is 525. It has been reduced to certain value because the depressions are cut. Therefore it has come down to 523.53 centimeter cube, and that is the correct answer. Now coming to the next example, that is example number 5, we are given an inverted cone. So there is a cone which is inverted, it is open on the top, it is filled with water to the brim, and the height of the cone is 8 centimeter, the radius of the cone is 5 centimeter. Now there are lead shots. Okay, lead shot means the spears, they are of radius 0.5 centimeters. Now these lead shots, spherical lead shots are dropped into this cone. Once you drop the lead shot, the water will flow out of the cone, and the amount of water which has flown out of the cone is 1/4 of the total water. So 1/4 of the total water has flown out by putting the lead shots into the cone. Now we have to find out how many lead shots are put into the cone so that 1/4 of the volume flows out of it. So let us assume that n lead shots are put into the cone. Therefore n lead shots will be, therefore the number of lead shots, that is n, is equal to the amount of water which flows out of it, that is 1/4 the volume of cone, divided by the volume of one lead shot. Now volume of cone will be 1 by 3 pi r square h, and 1/4 of that will be 1 by 4 into pi r square h by 3, and the volume of one lead shot will be 4 by 3 pi r1 cube, and simplifying we get pi r square h divided by 4 into 3 divided by 4 pi r1 cube. I can cancel pi here, and I get r square is 5 into 5 into h is 8 divided by 4, and here I have 3 and 3 gets cancelled, and I have 4 as it is, and r1 cube will be 0.5 cube. Now putting the converting the decimal into fraction, I get 50 into 10 by 5 into 10 by 5 into 10 by 5 divided by 1 by 4, and that will be 50 into 2, therefore n is equal to 100. Simplification you have to learn. Please learn this simplification. I have made it very simple by taking fractions, and therefore the answer is 100, and therefore the number of lead shots which are dropped into the what you call cone, and 1/4 of, so that the 1/4 of the water flows out, are 100 lead shots. So 100 lead shots are dropped into the cone. So try to understand that. Now coming to the sixth example, we are given two solid cylinders. One surmounted on the other. I have not drawn the figure here. You can draw it. There are two solid cylinders. One cylinder is at the bottom and another cylinder is at the top. There are two solid cylinders which are placed one over the other. Now height of one cylinder is 220 centimeters. If you take the bottom cylinder, its height is 220 centimeters, and the diameter of that bottom cylinder is 24 centimeters. Therefore radius is 12 centimeters. Now the height of the second cylinder which is surmounted on it, exactly in the center, it is 60 centimeters, and its radius is 8 centimeter. Now we have to find the total mass of the pole, including the bottom cylinder and the top cylinder. So we have to find the mass of that. The volume is 1 centimeter cube per 8 grams, or rather 1 centimeter cube volume is 8 grams. So that is what is given to us. That is very clear. 1 centimeter cube of iron has a mass of 8 grams. Now we have to find the total mass. The total mass is very simple, and the formula is we have to find the volume of the total pole. When we multiply the volume of the pole by mass of 1 centimeter cube of that material, we get the total mass. Now that means we have to find the mass of the total pole, volume of the total pole rather, and to find the volume of the total pole we have to add the volumes of the bottom cylinder and the top cylinder. And in both the cases we have the formula is the same, that is pi r square h. So the bottom cylinder volume will be pi r1 square h1, and the top cylinder will be pi r2 square h2, and we know that pi is 3.14. R1 is 12 into 12 because they have given the radius of the bottom cylinder as 12 centimeter, and the height is given as 220 centimeter. So I have substituted it here. Now 3.14 into height is 8, that is radius is 8 into 8, and height is 60. So simplifying this, we get 11,11532.2, and this is what is the volume of both the cylinders put together. Now to find the mass of the pole, we have to just multiply this by 8, and we get 111532.2 into 8, that is grams, but to convert into kgs I have to divide it by 1000, so I get 892.15 kilogram. Therefore the mass of the total pole, that is the bottom cylinder and the top cylinder put together, the total mass is 892.2 kilograms. So learn to simplify this. Main thing in surface area and volumes is simplification. So learn how to multiply, how to add, how to these are the main thing is multiplication and division. So we have to learn that, and you have to, don't use a calculator for this. Please do it yourself by your own hand so that you get the answer. That's what I have shown a bit of it here, and learn it. Okay, next, let us go to the next example. Now example number 7. A cone is surmounted on hemisphere. So there is a cone and it is surmounted on a hemisphere, and the height of the cone is 120 centimeters, radius of the cone is 60 centimeter, radius of hemisphere is also 60 centimeter. The solid, okay, this solid which is that is a hemisphere on which a cone is surmounted, this solid is what you call placed upright in a cylinder. Okay, it is placed inside a cylinder which is filled with water. The radius of the cylinder is again 60 centimeters. Now what we have to do is we have to find out how much of the volume of water is left in the cylinder. But natural, when the solid found by the hemisphere and the cone is put in a cylinder filled with water, the volume occupied by the cylinder and the cone together will displace the water will flow out of it, and some of the water will remain behind, and therefore we have to find out how much of water is left behind in the cylinder. Now for that, what we will do, let us find out the volume of the cylinder first. So find the volume of the cylinder and then subtract the volume of the solid combination there. Now volume of the cylinder will be again pi r square h, and let us take r1. The cylinder radius is 60 centimeters and height is 120 plus 60, 180 centimeters it is. So the height will be 180 because 120 is the cone and 60 is the hemisphere. 120 plus 60 will be 180 centimeters will be the height there, will be the height. Now let us proceed further. That is, let us understand how the calculations are done. So we have got pi r1 square h2 minus volume of hemisphere plus volume of cone, and the formula I have written pi r1 square h2 here minus volume of hemisphere is 2 by 3 pi r1 cube, and the volume of cone is 1 by 3 pi r1 square h1. Now in this, pi r1 square h2 minus 2 by 3 pi r1 cube plus 1 by 3 pi r1 square into height is 120, height of the cone is 120 there, and pi r1 square h2 minus 2 by 3 pi r1 cube minus 1 by 3 pi r1 square into 120, and pi r1 square h2 minus okay, h2 here, h2 I have taken, and I have taken, okay, pi r1 square is common, therefore I have taken pi r1 square outside. So pi r1 square is taken outside, h2 minus 2 by 3 r1 remains here, minus 1 by 3 into 120, and 22 by 7, r1 is 16 to 60, and as I have told you, h2 is 120 plus 60, that is 180 here, minus 2 by 3 into 60 minus 40. Now further simplification, 22 by 7 into 16 to 60, 180 minus 40 plus 40, that will be minus 80, and further simplification, we get 22 by 7 into 16 to 60 into 100, and this will be 2200 into 3600 divided by 7, and further simplification we get that is the 7.92 by 7, that is equal to 1.131 meter cube. And please try to understand here, it is 1.131 meter cube. That means meter cube means I have to divide the 79240 joule by 7 by 100 into 100 into 100, because to convert the centimeter cube into meter cube it has to be divided accordingly, and that is what I have done, and I got the answer as 1.131 meter cube. So try to understand the conversion of units here from centimeter cube to meter cube. So therefore ultimately the volume of that is water which is left in the cylinder is 1.131 meter cube. So try to understand, and if you have any doubt you can put in comments, I can further clarify on that. Now coming to the 8th example, we are given a spherical glass vessel with a cylindrical neck, height of okay, there is one spherical neck, spherical glass glass vessel with a neck in the shape of a cylinder. The height of the cylinder, that is the neck of the cylinder, the height of the cylinder which is the neck of the glass vessel is 8 centimeter, and the diameter is 2 centimeter. The diameter of the spherical vessel is 8.5 centimeters, and therefore R will be 8.5 by 2. Now we have to find out the volume found out. Okay, the volume is already found out, and it is found out to be 345 centimeter cube. Now we have to find out whether the volume which is found out already is correct or wrong. So the total volume of this glass vessel will be the volume of the sphere plus the volume of the cylinder. Therefore it will be 4 by 3 pi r1 cube plus pi r2 square h, because cylinder is pi r2 square h. Now that is 4 by 3 into 3.14, pi is 3.14, r1 will be here, that is r1 will be 8.5, yeah, r1 will be here, the volume, the radius of the spherical sphere glass vessel, 8.5 by 2, 8.5 by 2 and 8.5 by 2 plus 3.14, again r2 square. R2 is here, that is 2 by 2 into 2 by 2 into height is 8. Now further simplification, we can keep on simplifying, and I found out the value to be 321.392 for this, plus 25.12, and therefore the ultimate answer is 346.512. So what the volume what we have got is 346.512 centimeter cube, but the answer which is already given is 345 centimeter cube, which is definitely less than what we have got. Therefore what only we can say is the volume given is given in the answer is less, rather it is incorrect. So the correct answer is 346.512 centimeter cube approximately. Please, again I repeat, learn how to calculate this. Calculation is only important in this. Remember the formulas, apply the formulas, use the substitute the values in the formulas and calculate. So you should know how to calculate the decimals and the fractions and get the correct answer. Ultimately in these examples you should know how to do the calculations. Lengthy calculations, but they are very easy calculations. Only you have to have a bit of patience and get the correct answer. Okay, so at least approximate answer should be there. Okay, if it is 346.512, decimal value can be slightly different, but the main value, the whole part should be accurate or correct in the calculations. So please learn how to calculate, and then surface areas and volumes calculations will be very easy. So these were a few examples which we have learned to solve in this exercise. All the examples are important. Learn them, practice them. They are easy examples. Only you should know how to use the formulas, correct formulas, and then do the calculations. Okay, then note down them in a book as a reference for you. Okay, thank you.